Hey, boys and girls, this is the homework that you got on May 18th. So I just want to go over it. Now, your book, just an FYI, doesn't really go into analyzing box plots. It basically just has you make them. So that's why I just wanted to give you a few questions like this to kind of think about um, kind of reading them. So anyway, these two box plots represent the number of seconds that a random sample of 100 traffic lights are red in each of the two cities, Johnstown and Martinville. So there you go, the length of time traffic lights are red. Okay, and then, so the question is, based on the data in the two box plots, which statement about the difference in the medians of the two data sets is true? So first things first, let's look at the median for each one. So the median for Johnstown, if you look here, that the median is this one in the middle, that's 110. So Johnstown is 110. And Martinville, the median is 80. Okay? So the difference in those of those is 30. Okay? Now, the difference is about 2 2/3 times the range of the data for Johnstown. So here's Johnstown, here's the range. It goes from 140 to 80. So 140 to 80, the range for Johnstown, I'm going to write this down here. So the range for Johnstown it goes from 140 to 80. That's a difference of 60. So that's a range of 60. So the difference is about 2 2/3 the range of the data for Johnstown. So is this difference 2 2/3 times this range for Johnstown? Don't even worry about this here, about 2 times the range of the data for Martinville. Don't even worry about that. Just let's worry about, see if this is true. Is 30 2 2/3 times that of 60? And the answer to that is no. 60 is 2 times this. So therefore, A cannot be true. Let's look at B. The difference is about 2 times the range of the data for Johnstown. So let's look at again, 2 times, again, the range for Johnstown is 60. So this is not 2 times 60. So no, that means this can't be true either. Again, we don't have to look at the second part of it. If one part's not true, then the whole thing can't be true. The difference is about 3/8 times the range of the data for Johnstown. So again, the range for Johnstown is 60. Does 30 represent 3/8 of 60? So 3/8 of 60 means 3/8 times 60. So we go ahead and do all this. I can cross simplify here. 4 goes into here 2 times, 4 goes into there 15 times. So I'm going to get 45 over 2, which equals 22.5. So that means 3/8 of the range of Johnstown is 22.5. 3/8 of the range of Johnstown is not 30, so that can't be the answer. That means D should be the answer. So again, the difference we're talking about as 30. The difference is about 1/2 times the range of the data for Johnstown. Well, that's true because the range for Johnstown is 60. So the difference in the medians is 30, which is 1/2 that of 60. And about 3/8 times the range of the data for Martinville. So let's look at Martinville. We've never had to do Martinville because all the other ones for Johnstown weren't right. So Martinville is from 120 to 40. That's a difference of 80. Okay, so now the question is, the range for Martinville is 80. So is 30 3/8 of 80? And it is, because if you just reduce 30 over 80, you get 3/8. So therefore, D is the correct answer. All right, let's look at the next one. Which one of the following box plots has a 72 as a lower quartile? So lower quartile means if you look at the quartiles, Q1, 2, and 3, The lower quartile is Q1. Okay, so remember this first little dot here, that's the lower extreme, not the lower quartile. This is the lower quartile. So this one lower quartile is 60. This one has a lower quartile of 50. This one has a lower quartile of 16. This is the one with a lower quartile of 72. Perfect. Next one. A bowling team participates in a 2-day tournament and records the scores for each team member on both days. The scores for both days are represented by the box plots below. So here we go, Friday and Saturday. Which conclusion can be drawn from the box plots? So the scores on Friday and the scores on Saturday have the same median and interquartile range. So we can look here. The median for Friday, it looks like if this is 200 and this is 225, that means these are going up by 5s. So this is 205, this is 210, this is 215. So the median for Friday was 215, but the median for Saturday was 205. So that's not true. So I could ignore this interquartile range. It doesn't matter because it says it's the same have the same median and interquartile range. Well, they don't have the same median, so this A can't be true. So let's look at B. The scores on Fridays have a greater median. Well, that's true. So Friday's score has a greater median than Saturday's score, and a greater interquartile range than the scores on Saturday. So let's look at the interquartile range. So the interquartile range, remember, is Q3 minus Q1. So for Friday, that's going to be, so Friday, that's going to be 220. So this is 220. And this right here is 200. So the IQR for Friday, the IQR is equal to 20. All right, because I just do Q3 minus Q1. Now, we know that the median for Friday is bigger than Saturday. Let's look at the IQR for Saturday. So the IQR, Q3 is 210 for Saturday, and Q1, if this is going to be 195, this will be 190. So 210 minus 190 is 20. So the IQR for this is equal to 20. So it says the scores on Friday have a greater median, true, and a greater interquartile range, not true. They have both the same interquartile range. So we can skip that one. For C, it says the scores on Friday have a greater interquartile range than the scores on Saturday. We could stop right there. We know that's not true because the interquartile range is the same for both of them. All right. For D, the scores on Friday have a greater median than the scores on Saturday. That's true, but both data sets have the same interquartile range. We figured that out. That's true. Okay, a principal gathered data about the distance in miles that his teachers and bus drivers live from the school. The box plots below show these data. So based on the box plots, which statement is true? So for A, the interquartile range of the distances for the bus drivers is twice the interquartile range of the distance for the teachers. So the bus drivers, the interquartile range, let's see, it's going to be Q3 is 20 minus Q1 is 10. So 20 minus 10 equals 10. For the teachers, Q3 is 30 minus Q1 is 15, which equals 15. So the IQR for the teachers is greater. So this said the interquartile range of the distances for the bus drivers is twice the interquartile range of the distance for the teachers. Well, that's not true because 10 is not twice the distance it's not twice 15. So that's not true. For B, it says the range of the distances for the teachers is twice the range of the distances for the bus drivers. So let's look at the range. For the bus drivers, its range is the greatest minus the smallest. So for the bus drivers, it's 30 minus 5. So 30 minus 5 equals 25. And for the teachers, it's 35 minus 5. 35 minus 5 equals 30. So it says the range of the distances for the teacher is twice the range of the distances for the bus driver. That's not true because the range for the teachers is 30. Range for the bus driver is 25. 30 is not twice 25. For C, the interquartile range of the distances for the bus drivers is 5 miles less than the interquartile range of the distances for the teachers. Well, that's true Going back here, these were the IQR, right? So it's 10 for the bus drivers, 15 for the teachers. So it says the interquartile range of the distances for the bus drivers, which is here, the 10, is 5 miles less than the interquartile range for the teachers. That's true. So our answer is C here. Okay, a survey was conducted of 130 purchasers of new black sports cars, 130 purchasers of new red sports cars, and 130 purchasers of new white sports cars. Oh, you know what that says. In it, people were asked by the age they were when they purchased their car. The following box plots display the results. Which group is most likely to have an outlier? So, well, in this case, remember, an outlier is a number that's very far off from all the other numbers. And in this case, if you look here, the black sports cars, the middle 50% is right around here, has an age of, well, it's just like maybe like 27 to like 42. But look it up here. It has at least one person was in their, kind of in their later 60s when they bought a black sports car. Now, here's the deal. There's somebody that was even older that bought a white sports car. However, this number right here, this person right here, was really closer to the middle 50%. So they weren't that far off from the age that the middle 50% bought it. So I would say that the person who bought the black sports car, this person right here is that outlier who's very far off from the middle 50%. So I'm going to say it's the black sports car. Bum, 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 bum. Next one. Ruben put an empty cup underneath a leaking faucet. After 1.5 hours, Ruben collected 0.25 cups of water. What is the rate in cups per hour? So cups per hour. So how many cups are we talking about? We're talking about 0.25 cups in 1.5 hours. So let's go ahead and see which one matches this. So we can change both of these to whole numbers. So if I multiply this 0.25 by 100, it becomes 25. And then if I multiply this by 100, because what I would do at the top, I got to do at the bottom, this times 100 becomes 150. Now I can reduce this a little bit easier. 25 goes into itself once, 25 goes into 150. 6 times. So the answer is 1/6. Next one. The weight of a piece of wood is directly proportional to its length. A piece of wood that is 25 centimeters long. So 25 centimeters long has a weight of 5 grams. So if it's 25 centimeters long, it has a weight of 5 grams. Another piece of the same wood is 30 centimeters long. Calculate the weight. What's the weight? So we solved these already in class. We can cross multiply. 25 times x is 25x. 5 times 30 is going to be 6. No, it's going to be, nope. I'm sorry. It's going to be 150. So divide both sides by 25, and I have x is equal to 6. Now that would make sense too. If something's 25 centimeters and it weighs 5 grams, it makes sense that something that's 30 centimeters is 6 grams. So the answer here is going to be 6. Okay, the next one. Use the information provided in the sentence to answer questions 1 through 8. There's not 1 through 8 there. So the Super Shop is having a grand opening sale. Today's special includes 2 shirts for $25, 4 pairs of pants for $36, and 2 dresses for $44. The following question has 2 parts. First, answer part A, and then answer part B. That seems to make sense. Several clothing items were sold during the grand opening sale. A table of some shirt sales or missing sales with missing data are shown. So fill in the blank with the correct value. When 9 shirts are purchased, the total cost is how much? So we just look here at this very first one. We know that 2 shirts cost $25. So if 2 shirts cost $25, if I just do 25 divided by 2, I know that 1 shirt costs $12.50. So if I'm going to go ahead and buy, if 1 shirt's $12.50, well now if I'm buying 9 shirts, Well,